Basically, my topic is, about SoC, how we can design systems using single chip. To start with, I have a small question from the audience. Are you single? You are single. So what do you mean by single? Single means unmarried. Anybody else? Now, let's look at the embedded systems. I started my career 1991 when I started designing systems using analog components, transistors, all discrete components, where we used to take all the components, maybe sometimes, the board size used to be like a 1x1 fit, like motherboard kind of boards. And today when we design a system, we have a system just using a small chip. So where you have, the analog parts, digital, even amplifiers, even RF, the blocks, we will be having on the same chip. So what advantages we have from the SoC? Number one, we have a less space. You will be able to design the product where the form factor is really very, very less, very small form factor. Then second is low power consumption. You will be able to design the system, where your system will power up using a button cell which you are using in watches, right? Then what else? Form factor, power consumption, price. Instead of spending more money on your board designs or in your certification, so you will be having a single chip solution where price will be less. And as you know, most of the innovations worldwide, these innovations are driven by 4 Ps. So what are the 4 Ps? First is performance. So every day, we are looking for more and more speed, more and more performance. That's the first P. Second P we have, that's a power consumption. So MSP 430, which we are going to talk about, this is the world's number 1 ultra low power SoC, which consumes less than 0.1 microamps in ultra low power consumption. So that's one more P. And third is price. Now, if you look into the price, I think nowadays these chips are, that going down into like a few cents. Maybe you can find these chips, maybe cheaper than potato chips, right? So the third P is also very important. And fourth P, that's a package. So smaller the size, bigger the success. You have the complete SoC, which I will be showing you in the next slide. How it looks like an elephant. If you look inside the chip, it's a really big animal. But if you see the package, you will be having hardly 3 millimeter by 3 millimeter by 1 mm package, very small in size. I hope, in a couple of years, you will be having these semiconductor SoCs with a size of where you will be able to inhale it, couple of chips. That's going to be the size of the semiconductor chips. But if you look inside the chip, it's really big animal. You have everything which is needed in order to design a complete system. First of all, the heart of the chips is your CPU. So MSP 430 it's an orthogonal architecture where you can find, it's a highly flexible chipset where you can use any instruction, any peripheral. If you remember with, the 8051 MCS series, so where, you will be having a accumulator where you can use some typical instructions, let's say the rotate, left through carry or something. So those kind of instruction you have to use always. You have to use accumulator. You have the addition, subtraction. So these instruction set, always they need accumulator. So accumulator is your bottleneck. Now here you have the architecture, orthogonal, which helps you to use any instruction with any peripheral. You can, let's say you can, use it like a rotate port. You can say add something with a stack pointer. Normally you will find, why to add something with a stack pointer? Stack pointer is a very simple fellow. it points to the next instruction which is going to execute. After execution of this instruction, it will point to the next instruction. It works like this. But when you suddenly add something with a stack pointer or with the program counter, it jumps to the particular location. So without using jump instruction, it will jump to the particular location, right? So when you are implementing a RTOS on this kind of chipset in MSP 430, so you will be able to do more things in a less time, in a less memory space, right? And if you look into the nowadays, the kind of memories we have available, you have a huge memory available on a on-chip flash memory. You have a RAM up to 16 kilobytes. Actually, as you know, MSP 430, it's a family. I mean, today we have more than 450 devices. The flavors are available from MSP 430 family. I mean, everywhere you have a same 16-bit CPU, but you have a different peripherals, different memory capacity for different applications. Even you have some of the dedicated chipsets are available where you have some ASICs for energy meter, flow, the water meter, gas meter, right? Then we have power on reset, brownout reset, supervisory circuits, multiple UARTs. You have up to 4 UARTs. Then on the analog front end side, we have a comparator. Even some of the chipsets we have, built-in operational amplifier where digitally you will be able to control the gain. And based on the chipsets, now we have a value line series where, 1 port or 2 ports are available, and some of the chips we have up to 10 ports. 10 ports means, it will go up to 10 into 8, 80 IO lines are available, right? And some of the ports are interrupt-enable and some of the ports are the normal ports. But we will recommend to use always interrupt lines if you have some user interface, so that maximum time the CPU will spend into the low power mode. And as you know, it takes very less time to come into the active mode from the low power mode, right? It takes, I think, less than 204 nanosecond time to power up. Then we have DMA. This DMA is not just a direct memory access. You can access anything from anywhere. So let's assume if you have to generate some sine wave, right? Now instead of using CPU every time taking this data from the memory and pushing it to the DAC, now this job can be done with the help of DMA. So you have to assign DMA channel which will keep on picking up these values from the sine table and pushing to the DAC, and you will get beautiful waveforms. So you will be having a 2-channel DAC, right? In the same way, DMA can be used with a UART also. You are uploading some information from this system or you are downloading some information. DMA can be used along with the MAC also, where on the background you have to run, let's say, FIR filter. So DMA will help you to get these samples from ADC, right? It will help you to get some samples from ADC, and then the next DMA channel, it will help you to multiply the coefficients with the samples which we are taking from the ADC, right? So like that, a lot of things can happen in the background while MSP 430 CPU will be in a sleep mode, right? Because we want to save a power, and as you know, the CPU will consume more power and the peripherals are consuming less power, right? Then we have built-in LCD drivers, because when we talk about MSP 430, you can find a lot of MSP 430s. It goes into the handheld instruments, healthcare instruments. So that's where we need some kind of a user interface. So we have a built-in LCD driver. So you need not to use any special LCD module which will consume more power. So we will be having a family with built-in LCD drivers, basic RTC built-in. As I said, we have a 2-channel DAC. And we have very powerful ADC front end with 8 external channels with a sampling rate of more than 200 samples, 200 kilosamples per second, programmable reference voltage. In fact, this ADC will be having a 2 different groups, where you can select one for high speed and other for low speed. Since MSP, as you know, the mixed signal processor, so MSP is not just for one type of signal, so you will be able to get the mixed signals from the, let's say you have one group of low speed signals, another group you have a high speed signals. So definitely, you need to select a two different sampling rate for two groups. So we will be able to do that in this type of ADC. You have a built-in programmable reference voltage. We need not to connect any external reference. We have on-chip reference voltage, programmable. And two timers, timer A and timer B. So these two timers can select your internal clocks. As you know, we have a multiple clocks. We have a built-in clock, that's a DCO, digital controlled oscillator. External crystal, that's a 32 kilohertz slow speed clock. And again, high speed clock, 8 megahertz, 16 megahertz up to 25 megahertz. Now, why we have multiple clocks here? As you know, this chip is, ultra low power chip. So higher the frequency, higher will be the power consumption. So dynamically, you will be able to switch between high speed clock to low speed clock to the built-in clock DCO. You can use DCO also, but the problem with DCO is because it's a RC based oscillator. Normally when the battery voltage is changing, when your temperature is changing, you can experience this small variation in the frequency. So in some of these sensitive applications, we can always, switch back to the crystal oscillator after, the transmission of the particular data because when you are transmitting some information through wired communication or wireless communication, so that particular time you can switch to the crystal, and again you can switch back to the DCO, where frequency variation will not affect your performance of the system. So these two timers will be having a multiple capture compare register. So same timer, when you are generating a pulse width modulation, multiple pulse width modulations from this timer, at the same time you can use some of the capture compare registers to receive the feedback, like in case of speed control of a motor. So you need a multiple pulse width modulation channels. At the same time, you have to take a feedback from the motor. You have to sense the speed of the motor. So you will be having a feedback sensor, maybe proximity switch or a rotary encoder. So that input can be used with the same timer to measure a speed, right? And for a fail-safe operations, you have a watchdog, which can be used as a watchdog timer, or it can be used as a purely watchdog, where it will take care of your software health. In case the system gets hanged, you will be able to reset the system. So this was, this is how it looks, the complete SoC. I mean, this is a generic block diagram, but as I said, we have more than 450 devices in MSP430 family, but you will be able to find a lot of devices based on your application, like let's say dedicated to energy meter applications. You have MSP430 FE series, where you have a chipsets available especially for single phase energy meter, 3-phase energy meter, right? In the same way, you have some chipsets are available for flow meter also, for gas meter also, and some of the chipsets are specially designed for healthcare, for ECG, as well as for the pulse oximeter. Now when it comes to the look and feel, the feels like a butterfly because the chipsets are so lightweight, very small in size, takes less power. You can find this, your Fluke multimeter, world's #1 multimeter company. These meters are powered by MSP430. You can find water meters where you can use MSP430 continuously for 10 years, right? So because power consumption is very, very critical in these kind of applications. You can find MSP430 into HVAC systems, into the remote controls. Even nowadays, TI is having a special protocol for the remote controls. And you can find MSP430 into the wearable, like a shoes, right? Now, why will like to use MSP430 into shoes? Because we are human being, right? We don't have a wheels. If you want to measure a speed, we can't use a standard speedometer. So in that case, we have to measure a step size. So where we will be able to see how much, at what speed we are walking, how much distance we are covering. So maybe I think it's a combination of accelerometer and MSP430 where you will be able to measure your flight of your step, and you will be able to measure number of steps, and you will be ultimately able to calculate speed as well as distance, and that information we can transmit to the the another like wireless receiver, maybe a watch, where you will be able to read your distance as well as speed. Now if you see the modern 16-bit RISC CPU, we have, this is the, the registers. We have a program counter, stack pointer, status register. So all the flags, like a 0 flag, carry flag, along with you have a low power control bits. I mean, MSP 430, it's got a multiple low power mode 0, 1, 2, 3, and 4. I mean, instead of a simply, sleep mode and active mode, we have a multiple low power modes where based on the situation, based on the requirement, we will be able to power down the low power. And these control bits are available inside the status register. Then we have constant generator, which is internally used by the CPU. And R4 to R15, we have complete 12 working register. All these registers are 16-bit register, but if it is needed, we can use as a 8-bit register. You can, a move.b. So it means you will be able to access only the lower 8-bit register. But now if it is needed, you can use as a 16-bit register also. Now JTAG is something, which comes along with the chip, which is very powerful block, because most of the time, whenever you are doing a development, in order to, put your development into the fast track, so we need a powerful debugging tool. So, earlier days, we used to spend a lot of money to buy the emulators. So now the emulation part is on chip, just you have to connect a low cost JTAG debugger or SPI-by-wire. There are two different ways. One is SPI-by-wire, another is JTAG. So this JTAG block is a part of the chip itself. So that one is it will help you to download the program into the chip, and second is you can look inside the chip after downloading. You can debug it easily to see that what's happening inside a chip. So you can put a breakpoints. You will be able to check the memory, RAM, flash. You will be able to make the changes. Even, sometimes, let's say some hardware is connected to your chip. And after running this, running the program, if the hardware is not working, you will be able to stop the program. You can just force some values into the ports, and you can see that, whether port is really working or not working. So those things will be possible because of JTAG. So you have the software options like IAR is one option, and then CCE Code Composer Essential from TI. This is another software which you can use it along with MSP 430, as well as you have a lot of other third-party softwares are available for MSP 430. But as we know, like IAR is the best, which I am personally using it from the last 10 years. Now MSP 430, since it starts working from 1.8 volt and it takes, very little power, but you can find this chip, it's big in performance. You will be able to implement your FIR filter, where typically FIR filter will be working in a background. Since we don't have, the multiplication instruction in the instruction set, because it's a RISC processor, but you can find you have the dedicated hardware multiplier which can multiply 16-bit number with another 16-bit number, and it will add with the previous result in a single cycle. So these kind of peripherals will help you to implement FIR filter in the background, right? Now here you have a 3 DMA channels along with the timer and MAC. So these blocks will work in the background to help you implement FIR filter. So instead of putting the external filter chips or external analog circuitry, you will be able to get the complete solution in a single chip, right? So you can find a typical sensor like a smart wireless sensor, heart monitor, glass break detector, vibration analyzer, speech analyzer. Let's say, the glass break detector, I remember earlier days people, they used to put a thin wires on the glass, very thin wires. And normally, how it works, when the glass breaks, the wire loop will be open and it will trigger the alarm. Now today, if you want to implement a glass break detector, can you guess how we will detect the glass break in a security systems? Vibration means, now if you come to Electronic City, you look into the Infosys building, it's a huge campus, and we can't put, the vibration sensor to each and every glass, because you will be having maybe multiple patches of glasses. You will be having a one patch here, one patch here, one patch here. You have a lot of patches of the glasses. Acoustic, that's the best thing. I mean, maybe, there is a no sound for heartbreak, but definitely there is a typical sound for glass break, right? Now for a glass break, just you need a sensor. What kind of sensor? Just a 2 rupees sensor, microphone. And you have a built-in amplification in MSP 430 where, you will be able to amplify the signal from the microphone. And then what else? The signal processing comes into the picture where we have to find out whether really it's a glass break or something else, right? Because a lot of sounds are available. Sometimes, the sound comes if you break even this podium or computer. I mean, different objects will give you different kind of sound, but typically if you are looking for the sound, glass break sound, even you will be able to go up to the depth where you can find out, whether this is a framed glass or it's an open glass. Now what's the difference? Glass break is a glass break. Do we really need to check it whether it's a framed glass or open glass? Sometimes yes. See, let's say you take an example of your apartments. I mean, some of the buildings in Bangalore, you can maybe find, 200 flats in one single building. And we don't know how many glasses every day they are breaking inside their flats. Why they are breaking glasses? Husband, wife, they fight, they break, they start from kitchen maybe somewhere, right? They'll start breaking the glasses. Now we are not interested in detecting those kind of glasses because that's the internal matter, right? If somebody is breaking the glass, maybe by the end of the day, they will resolve the issue and evening they can find, in the hand in hand they will be going out. No problem. That's their internal issue. So we don't want to inform our security guys whenever there is any glass break which belongs to the inside the flats, inside the building. But when it comes to the framed glass, so our interest is to detect that framed glass break and it should, the message should reach to the security center, right? Now, using some fine algorithms, you will be able to detect, whether this glass break belongs to the framed window or whether this glass break was, maybe your nice dining table, right? So up to that depth, it will be possible with the help of this MSP 430 based application. Vibration analyzer, you can find an industrial application sometimes in the bearing, we have to, if there is a fault in the bearing, so we will be detecting normally by listening to the sound or to the vibrations. Then you have the wireless sensor network is another area where we are using MSP 430. Then speech analyzer, that's again, for a healthcare applications, you can use it. Then we have a lot of applications where, MSP 430 is being used, let's say for where we will be having, this kind of a smart plug where you have built an RTC with a temperature sensor, or you can find, where you want to check the budget for a smart building. Sometimes, I can give you example. Recently, I have seen our electricity bill, it was 5,000. I was just, wondering, so who is a culprit? Who is taking more power? Whether it's a washing machine or it's a television, or it's our air condition. So I was not able to figure out. And then, I come across this kind of products where you can have this smart plug which can be plugged into the normal plug, and top of this plug you put your television, your washing machine, and these plugs will be having a network through power line communication or wireless, where by the end of the month you will be able to check it, the pie graph on the computer, you will be able to segregate and you will be able to find out where is the power consumption, more power consumption in which part. So that, let's say, if your air conditioner is having more power consumption, you will be able to find out some, the Energy Star rating, so that you can, sell that product and you can buy the product which is having a less power consumption, right? Plus you will be having a built-in controls, RTC control. It can, switch on and switch off the device as per your time settings. Now, as I said, energy meter is one area. I think in India we are having a more than 70% market share of energy meters based on Texas Instrument chipset MSP 430. I mean, another maybe you have ST, you have analog devices, but most of the energy meters in in the industrial as well as in the domestic, these meters are powered by MSP 430 because these chipsets are having a special ASIC inside MSP 430 which will take care of your measurements like active power, power factor. So all these things are taken care by the ASIC, and rest of stuff, maybe the housekeeping, display, communication, that stuff is taken care by the MSP430 normal generic CPU core and peripherals. Because energy meter is having a lot of challenges, especially the theft, tampering. Now sometimes people, they will change the wiring or they will do something so that your chipset is not getting power at all. So if chipset is not getting power, then definitely you have a big challenge. It will not able to sense anything whether tampering is happening or not. Now in MSP430, since it takes very low power, even it can draw the power from the current sensor itself, let's say CT, right, current transformer. So that output is enough to power up MSP430, and based on that power it will continue to do the measurements, and so that ultimately it will be able to detect your tampering also, and it will continue for the measurements also. Automotive applications you can find recently in MSP430 family. TI has added 50 more devices for automotive grade, where you can find some of my favorite applications like a smart speedometer. Now if you look at the speedometer, it looks same as it used to look maybe 50 years back. Same black color dial and orange color needle. So how this meter is different? Look and feel is same. I mean, when we say electronic speedometer, doesn't matter, it will be having a digital display. Why not digital display? Digital display means poor readability, and you will not have the beautiful look of the pointer. I mean, if you look into the European market and everywhere, even if you look at BMW, Audi, all these vehicles, still they will stick to the same pointer. Now, only in the earlier days, what was the disadvantage in these meters? It was completely mechanical. Whole thing was driven by the moving wire. So every year, maybe after 6 months, you have to change the wire, right? So there was a maintenance. Now these meters are having no maintenance, because this needle is still there, but this needle is not driven by your moving wire from the wheel. This needle is driven by the micro stepper motors, and where you have a signal coming from the moving wheels, that's a contactless sensor, maybe you can say Hall effect sensor or proximity sensor. So the wire is electrical, there is no moving parts there, so that's where it's more reliable. Plus we will be having a digital display that only belongs to the odometer part, as well as you have some critical messages. Let's say sometime, during a maintenance, your servicing guys, they will put the next reading for when you have to change this engine oil, when you have to change the spark plug. So all this information will be added, information will be downloaded during a servicing, so that it will remind you for the next maintenance. Then tire pressure monitor, air conditioning, heating, mirror and seat positioning, reverse collision detection, security system. See, especially the tire pressure monitor, it's very interesting, I mean, tire is something which is moving. Now you can't have some instrument, with the wires while, the wheels are running. So you can't take any measurement from the 4 wheels. So you have to have a very small in size. Maybe you will be having some small cap kind of thing. If you put this cap, that cap will be having a sensor, pressure sensor. After pressure sensor, you will be having a chip which is doing the instrumentation part, measurement part. Then you will be having a radio block. So all these things can be achieved in a single chip. Now since MSP430, the latest version, CC430, which is having a built-in radio on single chip. I think hardly it is available for maybe $1 or $1.5. So in a single chip, you will be having everything. Just you have to add your MEMS-based pressure sensor to this particular chip, and you will be having a readings coming out from all the wheels to your dashboard, where you will be having a very small device with the LCD driver built in, which can display your tire pressure. And as you know, the tire pressure, how important it is. I mean, if tire pressure is less, you will get less mileage. You will be tire life, normal tire life is maybe 3 to 4 years. It will come down to maybe 5 minutes if tire pressure is really dangerously low, right? So mirror and seat positioning. So all these things are so common today, even I'm not talking about the high-end vehicles. Even if you start with any model 5 lakhs to maybe 6 lakhs, 7 lakh, you will be having even the mirrors positioning is through the joystick, right? Then you will be having a Bluetooth interface whenever the call comes. So instead of taking your phone will get connected to your system, or maybe whenever SMS comes, it should come to the heads-up display, that kind of stuff. So all these things in the coming years, because they want to sell their products, there is more competition, they want some new features. So new features can be added, the new intelligence can be added definitely through semiconductor. Wireless sensor network is another area, the things of internet. I mean, that was the last topic. So everywhere we want, things should talk. I mean, the chair should talk to me, the projector should talk to me, my phone should talk to me, phone should talk to the car, and car should talk to the security guard, or maybe it should talk to the parking. So all these things are, they started talking to each other. Now, that's where, if you want everything should be talking, so there should be some intelligence, there should be some communication, and the best communication at low power that can be achieved through MSP 430. Because when we are talking about, things will start talking, so we will be having a built-in power source. These power source should be at least maybe 4 to 5 years battery life, or maybe lifetime battery. There should be some kind of harvesting power mechanism. I mean, if it is, something outside, so you can charge those internal batteries through solar, or you can charge it through ambient light, or you charge it for these kind of lights, right? So the biggest challenge is power source, and MSP 430, as we know, this is the world's #1 in ultra low power consumption. So it is the ideal fit for wireless sensor network with built-in RF connectivity block on a same chip. Plus we will be having a very powerful front end, so that sensor means you will be having a temperature sensor, you will be having a light sensor, you will be having a vibration sensor. All kind of sensors can be connected to this particular chip, because it's a mixed signal processor. And this chip can handle all kind of signals, even biomedical signal. You can think of patients will be having these kind of different kind of sensors, and with the help of a smaller batteries, we will be able to power up a system. This particular slide which I am showing, this is from the Kerala forest, where the government is interested in protecting the forest, because especially the sandalwood trees, the area it's a huge geographical area where the boundary wall or fencing is not possible, and we can't put the security guards for each and every tree guarding these trees. So we need to have some mechanism. So what kind of mechanisms we can think of for protecting this forest? Wireless sensor network. Now first is, you must have seen the small bottles of homeopathic, the sweet pills, small bottles. So we have done some experiments. We can make a very small PCB, like a maybe 8 millimeter width and maybe hardly 10 millimeter length. So this kind of PCB with MSP 430 plus accelerometer and battery, packed everything in a small bottle, hermetically sealed. Now you have to make a drill inside the tree, and in this hole you can push this bottle and seal it. Now what happens, whenever somebody is trying to cut this tree, maybe it's manually or with a motorized cutter, first thing is we have to sense the vibration. I mean, the vibration also, we have two different type of vibrations. Maybe now sometimes, you will be having a lot of monkeys jumping on the trees. I mean, that vibration, we are not interested in that vibration. These guys, let them play and have fun. But in case if they get the big monkeys, human being is trying to cut a tree, so we are interested in detecting those kind of vibrations. Now we need just $1 device, that is accelerometer, available from Freescale, since TI is not manufacturing this particular accelerometer. This accelerometer can give you analog output as well as digital output. If it is a digital through SPI or I2C protocol, you can interface with MSP 430 and get the streams, where the accelerometer chip is in the mode of vibration mode. I mean, you have two modes. One is acceleration mode and other is tilt mode. Tilt mode will, sense the angle. I mean, that also will work actually, but that angle will be too late. I mean, when somebody is cutting this tree, you cannot take the tree at same angle. The moment you cut the tree will fall and it will give you the alarm. But that is too late. Maybe, sometime it takes maybe 5 to 10 years to grow a nice tree, and somebody will cut in 5 minutes. So we want to detect immediately. The moment he will start, immediately it will pick up the vibrations and it will sense it. And after the next thing will be, we have to transmit the message. Now we are talking about the sensors, MSP 430 based, where the wireless transmission power will be very, very low. Now the small tree, the small fellow with a small sensor, it cannot shout, hey, save me. I mean, this message cannot go up to 10 kilometers. Definitely, the message will go with a multiple hopping mechanism through networking, sensor network. So that can be solved with the help of Zigbee, or you can have a proprietary protocols, right? And there should be some healing mechanism in the network. So maybe, I am sending this message through, one person was sitting here. So my protocol was designed based on this person. So I'm sorry, this person is not there now. So instead of, changing the whole software, and we are not going to call the administrator, please update my software because I cannot send my message. So there should be some healing mechanism. If this person is not there, doesn't matter. I will find out the new guy, and I will make sure my message will be routed through some other nodes. And finally, there is one gateway on the back side, where the gateway is responsible for sending the message to the security guards through GSM, through SMS, right? So, but ultimately the message should flow through network. Along with the trees, you will be having a bigger challenge for wildlife habitats, because trees, after all, it's a fixed infrastructure, right? I mean, you can assign some priorities. You will be having a star network, mesh network, and you can define these are the endpoints, this is a coordinator, this is the router. But in case of elephants, I mean, if you take this particular scenario, it will be very difficult to assign a configuration. I mean, you cannot take a couple of elephants and you can say, oh, you are really nice guys, and you always be there in a star network. So when you go for a walk also, take all the elephants in a star network, So that's not possible. All the elephants, they will go in a different directions, and again you have to figure out how to configure the mesh network and star network. So there you need a healing mechanism where, based on their locations, they will be, each and every node will be running a, we call it as a location engine. So they have to reconfigure it, and they have to find out based on their locations. Again, they will configure it, endpoints, coordinators. So this is a very interesting area. You can find a lot of people in universities, they are doing a research, and at Gill Instruments, we help these people to, we support in terms of hardware, all the resources. Precision agriculture is another area where you can find, you can collect the data from the crops, and you will be able to take the measurements of humidity, moisture, sap flow rate, and based on these parameters, when you are uploading to the system, you will be able to decide, what kind of water fertilizer expenses you will be having. So you will be able to get a better yields from the crops. The building automation is another area where today you can find a lot of electronic semiconductor. It goes into the buildings, and I'm sure one day you will be having a more semiconductor in a buildings than number of bricks we are using in the building. I mean, security systems, you have a lighting control, all these lights. Maybe after 5 years, next time when I will be here, these lights will be like LED lights, right? These whatever lights we have, the current lighting system, I mean, you have the CFL that's having a lot of mercury, so it is very difficult to, they recycle it. So LED lighting is a new lighting which will be, everywhere. You will be able to find whether it's a industry or it's a domestic market. They are going towards LED lighting. Now in LED lighting, as you know, these lights are driven by a semiconductor. It could be, the SoC or a couple of MOSFETs for driving the LED strings. So once the semiconductor comes into the picture, into the lighting, then definitely we want more intelligence. Intelligence in the way, let's say we will see that if this particular area, nobody is sitting here, we can make the lights off, right? Or based on the need, we can put the light, or you will be having the lighting system will be connected to the central server. So based on the holidays, your complete calendar can be uploaded to the lights, right? So you have a digital video, security access control, fire detections, HVAC systems, smoke control, indoor air quality, energy management, water management. So a lot of areas you can connect with each other through wireless sensor network. And finally, you will be having a servers where you, from the central location, you will be able to monitor and control everything. And the network topologies, you have the star, mesh, cluster, tree, right? So these different colors, they are showing a different functionality, like a PAN coordinator, full function device, a reduced function device. Biomedical instruments, you will be having now, the days to come, you will be having more and more instruments, wearable instruments. So when the patient comes to the, the ICU, you can find after seeing the number of wires, the patient, they will feel, oh, today the last day. I mean, if you give it very lightweight wearable medical instruments where the patients, they will be able to easily move, at least, they will feel relaxed when you have the less complications around them. So starting from the portable ECG logger, central monitoring system, inspirometry flow meter, blood pressure monitor, blood glucose meter, then from the sports side, we have speed distance monitor. So a lot of applications are coming up based on MSP430, because all these devices, we want, the long battery life and more signal processing inside a single chip. So all those things can be achieved through MSP430. Real-time continuous glucose monitoring. I think in India we have more than 30 or 40% population suffering from diabetes. So instead of taking the blood sample every day 2 times and then putting into the, the strip for a testing, you can think of non-invasive way of taking the measurement. And some of the, the companies, they are working on the non-invasive continuous glucose monitoring, where system will be completely sealed so that the patients, they can even go for a swimming. It's a completely packed, sealed, so there is no way of even, entering the water. So and you can upload the information to your laptops. You can see the real trends also in the real time. And then we have a development tools which we are manufacturing from the last 10 years. We have a wide range of development tools for MSP430. So if you are interested in, let's say, developing the application on MSP430, you need not to start from scratch. We can help you to start something like with a basic training of MSP430 to understand the nuts and bolts of MSP430. And if you are interested in mass storage device, where you are interested in connecting your media like a pen drive or SD card, you want to store some information in the file system. So we have recently some instruments where you have a wireless connectivity. So we can say, the wireless data logger, which can be used as a bedside unit, and it can get the information from the 6 patients simultaneously, and all the 6 patients data will be stored in a single MSD device through wireless or wide protocol. I mean, we have some special modules where you can hook up MP3 player, so this can be used as MP3 reference design also. You have RS485 Modbus connectivity, so it can use as a centralized data logger. You can hook up, up to 32 PLCs. So where each and every PLC can, store the information here into SD card or in a pen drive. Then for TCP/IP applications, we have embedded web server. So where MSP430 will be having a complete TCP/IP stack, it will be having HTML web pages, and we have one chip from Saris Logic CS8900, which will help you to, connect with the internet through RJ45 connector. Wireless sensor network, as I said, we have the reference boards, which can help you to design the systems for building automation or for healthcare. So especially, these kind of devices are having a very, very low power and the data rate is very high. These boards are, like it supports 2 megabit per second data rate, which is pretty high. Even you can think of audio can be converted into digital, and the streaming is possible through these chipsets, unique chipsets. I mean, in the wireless part, we have a modules from Nordic Semiconductor, and the baseband processor is MSP430. And some of these modules are, it will help you to connect with the 6 channels simultaneously in the star network. And we have gateways based on these boards, you can sandwich. These are piggyback boards. So once you make a sandwich of these 2 boards, so you will be having a short range wireless, and plus you will be having a GSM connectivity. So that's for the last mile connectivity. Let's say if you are collecting the information from the multiple sensors, maybe in the forest or maybe in the patients. So ultimately you need a long range connectivity where it will get connected with the server. It will start pushing the information to the servers. Like I have shown one sensor, that's ultrasonic sensor. Now if you take the combination of this particular base unit and this sensor, if you make a sandwich, can you think of any application? Ultrasonic sensor, which is measuring a distance, right? And on the other side you have the wireless node. This can be used in a parking lots, multi-floor parking. So wherever you have the one place for a car, you will be having this sensor, right? So whenever car comes here, you will be having a less gap. When car is not there, you have a more gap. So now instead of doing the wiring, now if you go to our Forum Mall, you have maybe I think 5 or 6 floors for the parking. Now what happens, instead of doing the wiring for checking that which car is available, sometimes when we go for a movie, so half of our time goes in searching the parking lot, by the time half movie is gone and we'll come back. So instead of searching that, once in the entrance itself, you will be knowing that where exactly you have the parking slot available. So the indication arrow marks will guide you, please come here, you have a parking. Chairs only, right? Even in case of a theater also, even if we go for a movie, sometime it is difficult to locate your particular chair, right? If you have some RFID based ticket and that ticket, easily it can talk to the particular chair and it will show you the color or some number, please come here, you have a seat here. So these things that's again, instead of doing a wiring for each and every chair, for each and every, where you have the glow sign or something on the chair. So these things can be solved through wireless sensor network. This is just, here itself I got this example. I think this could be a very good idea to have a RFID or some kind of wireless tags for the chairs in the theater. This is a big pain, right? Whenever you go for a movie, so lot of time you will be struggling and you will be falling to find out where is my seat. So now if you have something, your ticket is RFID based. So you, in the beginning of the chair, you show your tag, and from here itself it will show you that blink, Once you touch, it will show. So it means it will help you, it will guide you, it will navigate you to your position. So these kind of application, you can't think of doing a hard wiring stuff. So it must be, wireless, which can be achieved through wireless sensor network. Then MSP 430 workshops. We conduct workshops for corporates. We conduct workshop for the universities, institutions who are new to MSP 430, right? And if you have a basic, concepts of 8051 or even if you know MOV, move instruction also, that is enough to learn MSP 430, right? Because these are 100% practical topics. What's next? Go for single. As we started single chip solution, so single is better. So single means, which single I'm talking about? Single chip solutions, right? In real life, it's up to you. You want to go for single, double, triple, in terms of usability, easy to use. Not bothered about what kind of code it is going to download in this one. Basically, when you are writing your program, you can write your program in C, you can write your mix also. But once you compile it, ultimately, it will be zeros and ones. The hex code, some file format is there, which will be downloaded.
How do I download it into the MSP 430?
Through emulator, JTAG emulator.
Through the
JTAG emulator, yeah. So JTAG will be connected to your target board. So it is not just a downloading. After downloading, you have to debug also. So it's a real-time debugging. Because normally, some of the processors, when you download the program, it will use some resources from the CPU when you are going to debug it. Now here, the on-chip emulation is totally dedicated emulation, so it will not take any resource from the MSP430.
Thank you.